Okay. All right. So I just want to go through an example to show you some of these things that been talking about with regard to ILCs. In general, I have to say that there's no like recipe in order to judge whether something is good or bad. You have to take it case by case, and there might be peculiarities and difficulties in one ILC, and in a similar ILC, everything will be smooth. So um, that's the way things go here. So I just want to show you a couple of results and stress some points. So the first thing has to do with this ILC was run mm, more than 10 years ago. Uh, Different countries in Southern Europe, from 1 kilogram to 100 milligrams. Um, and at least one of the standards that was circulated showed this kind of a behavior when we were assessing its stability. So you see, initially, the measurements um, were along some average, some line, and then after some time, uh, so this is before the circulation, this is after the circulation, where there was a shift in the average of these values. So this is a jump, obviously, and we had to add stability uncertainty, which is typically, for jumps of this sort, is typically calculated as the magnitude, the absolute value of the jump, half of that divided by the square root of 3, assuming a rectangular distribution. So this is one thing. This is, in mass metrology, this is very typical. Um, Unless someone is very, very careful with the mass standards, you will see behavior of this sort. For another, for the 1 kg mass, the behavior was of this sort. So initially, we had two values that were determined here, then the circulation, and then after the standards returned, three values here. So my question now is, how would we analyze this? Is this a step jump, or is it a linear drift? What do you think? Hmm? Hmm. What type of a change is this? Is it a step change, or is it a drift? How would we evaluate the uncertainty associated with this change? It's kind of like a trick question, so you have to think a little bit about it. You also have to know a little bit about mass metrology. So obviously, the way that you're going to analyze this depends on the artifact and the transfer standard also, okay? I won't say anything else. I just want to see what you guys are going to say. Yeah. Anyone? No one. No one is brave enough. So this is the type of reasoning that someone has to go through when they're analyzing results or they're looking at results from an ILC, okay? Um, and draw from their knowledge. So if this was electrical type of an instrument, which are known to drift, then I would consider it most probable that that's a drift. But because it's from a mass, and masses typically don't drift, okay, they show step changes because some dirt either sat on them or because a piece of them was brushed off. So because of this fact, my first choice would be a step change, okay? And in fact, if I do not have any available information, other information with regard to the change, I use the one with the compatible with the least amount of information, which is a rectangular distribution um, with a step change. Okay, but in principle, if someone saw this type of a variation with time, you can say, well, oh yeah, nice, it fits nicely to an exponential here, or something of that sort. Um, okay, so that's one point that I want to make. You have to be careful and you have to consider things when you're looking at ILCs and the results. It's not just a recipe, I do this, I do that, I do this, I do that, and I finish. Okay, um, the assigned value is a reference value, okay, and these are differences of the different labs participating from the reference value as determined from one pilot lab. Okay? So one pilot lab determined this reference value. It's not by consensus. It was determined, and these are differences. What are shown here are differences from this reference value, which is this line here, the 0 line. And this is the uncertainty of the reference value. So how is the uncertainty of the reference value calculated? It's the uncertainty of the reference lab, how it's determined by the reference lab, plus the uncertainty of any instability that might be evident within this reference value. Okay? So this is how these two red lines were determined here. Obviously, this lab, which has the smallest uncertainty, so at first glance it would be the best lab, but unfortunately it can't measure correctly because it's the farthest from the reference value. And in this case, the EN number is calculated as the difference between the ith lab and the reference divided by the expanded uncertainty of the reference and the ith lab. Um, okay, I think that this is clear enough. There's nothing to say here. What I wanted to show is that a way of presenting results is with respect to the reference value. So the reference value is 0 here. And because we're talking about differences from the reference value, and the two red lines are the uncertainty of the reference value. Okay, same results as the 1 kg here, but here the assigned value is through consensus. So instead of using a reference value, the weighted least squares were used in order to determine the assigned value. So now you see, again, the picture is the difference from the reference value, or the assigned value, I'm sorry. So here we are. The red lines are the uncertainty associated with the assigned value as determined through the procedure of weighted least squares. And the rest are the results. They're the same results as here. 1, 2, 3. Yeah. There's one extra one, I think, here, which is what used to be the reference lab in the previous slide. So what would you say about these if you looked at them from this first graph here? What do you think? How many of these labs seem to be have satisfactory performance? Which? 4 and 3. 4 and 2. Speak up. Yes? Okay. Anyone else? Do you agree? So at a first glance, without calculating any EN number, I would say that the only two labs that seem to be okay with this procedure are 3 and 4. They're outside. The last two are outside. Well, yeah, okay. I mean, you don't have enough resolution to know if they're on it, within it, above it. But the ones that are clearly satisfactory are these two, it seems, okay? All right. Well, if that's the case, then we would want to determine if we have any discrepant data and reformulate the reference with respect to the information that's available, which is not discrepant. Okay, so then we would do a normalized deviation calculation, okay? And these red lines are the lines corresponding to a 5% significance level. That means that there's a 5% chance that just by chance, there's a point which is lying outside of these two lines. So anything within the two lines is 95% non-discrepant. So the probability of it being non-discrepant is 95%. Anything lying outside, there's only a 5% chance that they're there by chance. Okay? So these 4 points, which do not cross this reference line, their error bars do not cross this reference line at all, are classified as discrepant points. And since they are discrepant points, then they, in reality, they're considered outliers. So they should be excluded from the formation of the assigned value. Okay? So we do not want to just bunch everything together and find something. Okay, so that's simple. But is it correct, is the question. So there's a bit of statistical analysis that someone has to do in order to decide which of these measurements are to be used in forming the assigned value by consensus. Okay? And based on the procedure that I showed you previously, where we find the normalized deviations, that is the difference of each point with respect to the average, the weighted average, divided by the square root of the uncertainty of the point minus the uncertainty of the average. Why minus the uncertainty of the average? Because there's a correlation there, and it has to be taken into account. So once that is done, then the new average is this blue line here, and the uncertainty is determined, is these red lines, and now everything seems to be consistent, huh? So here everything is inconsistent, same numbers, everything is inconsistent. I redetermined the assigned value by discarding outliers, and now everything is consistent. So everything is consistent with the new reference value. Now, why do you think this might have happened? We are calculating the weighted mean, okay? So the weighted mean here, top graph, we have that situation. All but 2 points are not passing, those not satisfactory. And here, all of them are satisfactory. This is pretty tough, actually. It's not a simple, process. But this is really what someone who evaluates ILCs and ILC results should be looking for. It's not just a number of EN greater than 1, okay, no pass, less than 1, pass. Does anyone have an explanation? Can you offer an explanation, maybe? So first of all, the reference value here has shifted by about 0.4 units as compared to this one here. This one was at 0, and now it's shifted to a little bit over 0.4. Why do you think that happened? After? Yeah, right. Definitely. Lab 5 is the key. It's the key. Why is it the key? Because it's got the smallest uncertainty. Okay? So it tends to draw everything to itself. That's why this reference value is lower than the reference value when this is excluded. Okay? Plus, look at the limits here, how small they are. The limits are so small because they're basically determined from the uncertainty of that point. Okay? So once we exclude that, then everything is determined by these 2 points, which have much higher uncertainties, and that's why you have larger bounds. Okay? So now everything fits in. Any comment? So the EN for labs 3 and 4, it says are calculated by including 3 terms for the uncertainty. One is the lab uncertainty. The other is the stability minus the reference. Why? Minus? Again, because of the correlation. What do we mean correlation? We mean that these 2 values were used already to calculate the reference value. So we have to account for this. Okay, that's why we don't add it, we subtract it. They're anti-correlated, actually. Same situation, but now a robust estimator was used. The median was used. So again, there's a different, a different final picture here. Where now the lab, again, with only the lab with the smallest uncertainty is the one that has an EN number which is larger than 1. All the others pass. Okay, so this is an example, I guess, of lying with statistics. So take your pick. So which one to use really depends on the circumstances. So you can present the results any which way someone likes, but the correct way is dependent on what the circumstances are. Now, I don't remember, to tell you the truth, what the actual situation was here. But the thing to come, why is this excluded here? This is the point that I wanted to make. Why is this point not drawing the reference value to it? Because this is a robust estimator, and that's what the robust estimator does. It's not influenced by outliers. So it doesn't look at it at all. Okay, I have here our reports to show you. I don't think I will do that because there's no point in presenting a whole bunch of. Um, you've seen reports. Um, you've probably produced reports also from ILCs and PTs. They should have all of the information that's necessary for someone to conclude as to whether the participating laboratories had had a successful participation or not. And if possible, there should be um, comments which the laboratories can use for improvement. Okay. So the reports shall include, besides all the formalities, okay, a confidentiality statement. This is important with regard to proficiency testing. Confidentiality is an important issue, okay, and it shouldn't be overlooked because a lab could be defamed because of PT results. So it's always it has to be handled with a degree of um, you know what's the word now? I think you understand. Um, so there should be a description of the items, stability, comments, results, um, the procedures that were used to establish the reference values, assigned values and summary statistics in the form of graphs, comments or recommendations, info on the design and implementation of the PT scheme, and a mention at least of the statistical procedure used for the analysis and advice for their interpretation. So it's an actual report, really, more so than a calibration certificate, I would say. It has to have much more information because there are issues with regard to the interpretation. Okay, the final thing that I wanted to discuss, because it was brought up yesterday, I guess, is how to link comparison results. So what we mean by linking comparison results is to have a lab virtually participate in a CC comparison. So even though it hasn't participated in a CC comparison, we want its results to be presented as if it has participated in a CC comparison. So in order to do that, we have to estimate a correction, which is an offset and an uncertainty, to apply to the measurements obtained in the comparison to be linked through the performance of the linking labs. So what are the linking labs? The linking labs are the ones that have participated both in the CC key comparison and in the next tier key comparison. The corrected results then represent the best estimates of what would have been the results of the linked laboratories had they actually participated in the master key comparison. Okay, this is what I said with different words earlier. So let me try to summarize this thing. And this is let's say that it's an example of a Uramit key comparison, which is to be linked to a CC key comparison. Okay, so let's concentrate on the picture here, the diagram, and let's read the definitions. So first we have XR and an uncertainty associated with it, which is the CC key comparison reference value and uncertainty. So this red line here is the CC key comparison. This is a comparison that the lab has not participated in. XR, EUR, and the associated uncertainty are the RMO comparison, provisional reference value and uncertainty. So this is here. That's the value. Okay. And DIER and DIEUR and UIEUR are the offset and uncertainty of the provisional degrees of equivalence of one laboratory having participated in the RMO comparison. Okay? So what is that? This is the result of one laboratory, and the uncertainty is, why is it doing this? It's giving me a hard time. Disappears the arrow. And this is its uncertainty. So this is the CC reference. This is the RMO reference. This is what the laboratory has done in its comparison. So these are the degrees of equivalence with regard to the Euromet, the RMO comparison, and its uncertainty. So what we want to do is we want to go from referring this number to this, we want to refer this number to that. So basically we want to find something that connects these two. Okay? Well, the difference between the two is given by this expression here. So let's see what it is. Oh, I have to mention before we go here, I have to mention something else, that there are also some laboratories that have participated in both comparisons. So both in the CC and in the RMO comparison. So these are termed sub-CP. So the difference between this value and this value is equal to the difference in values from a laboratory that has participated in the Euromet comparison minus the corresponding value from the CC comparison. Do you understand? This is giving me a hard time. I have my mind. I don't know who's watching on over the internet, but they can just listen. What's the matter with this now? Isn't this working? You know, Abdullah? What's its problem? Okay. All right. So This is the difference that is of interest to us. It's the difference between these two values here. Okay? This, what? What can I do? Okay? So, this value here is the difference between let me see how I can put it. So I want to express this value here in terms of the value that was gotten by the lab that participated both in the Euromet and in the CC comparison. And this value, which is the reference for the Euromet, is the lab value with double participation in Euromet minus its degrees of equivalence. Why? Because the degrees of equivalence are defined that way. And the reference value of the CC comparison, again, is the value of the lab with double participation in the CC comparison minus its degrees of equivalence in the CC comparison. Okay? So I'm just rewriting this difference, including these degrees of equivalence of the double participating lab once the degrees of equivalence are with respect to the RMO comparison and once with respect to the CC comparison. And then this is rearranged a little bit, and we have this plus that. Okay? So this we can throw away because it's assumed that the value that is obtained by the double participating lab in Euromet and in CC is it's almost the same because this lab has a stable, it's known to have a good reproducibility. So that's an assumption. Okay? But typically these are the best labs in a loop, and it's reasonable to assume that the results are reproducible. And what's left over then? It's the degrees of equivalence in the CC comparison of the double participating lab minus the degrees of equivalence in the RMO comparison of the double participating lab. So then this difference is equal to this thing here. Okay? So we know what this difference is equal to. And obviously then the uncertainty of this difference will be the uncertainty of the double participating lab here and the double participating lab in the RMO comparison. Now, what does that have to do with what I'm interested in? Because really what I'm interested in is this quantity here. I want to refer this value, instead of referring it from here to there, I want to refer it from here to there. Okay, so I want to have this plus the difference between these two. Okay, this is the degrees of equivalence of the lab that is to be linked, the results of the lab that are to be linked. Okay? So These numbers here, this, is done for the linking labs. So this is true for all of the linking labs. So that's why BIPM says that there should be at least 2 linking labs. The more, the better, because then this correction that is applied to shift basically the degrees of equivalence from here to there to here to there, okay, is averaged from all of the double participating labs. So the average of all of these quantities from the double participating labs and the average of these uncertainties from the double participating labs make up this shift from reference value to reference value, and the corresponding uncertainty, which is called U-link in this instance. Any question? Look at it a little bit and so really, what does linking mean then? It means referring the value that I got with respect to the RMO, referring it with respect to the CC. What's that? No, it's not done by the BIPM. It's done by the pilot, whoever is running the key comparison. But it's not that difficult. You need the information. Which information? You need this information, which is available because there are reports. You can use the reports to determine these things and the uncertainties, of course. So obviously then the linked result will have an increased uncertainty. So it's not just the uncertainty that it had when it was referred to the RMO, but it's that plus something else. There are other ways of linking also.
How the pilot lab will be.
This is what you're talking about. No. The reports are published in Metrologia.
Published.
Yes.
From the
So the RMOs do not run key comparisons before the CC comparisons are finished. So these results are known. It's happened because of another reason. What, mass? Yeah?
waiting for pending. But we are waiting for in temperature. Temperature. Still pending. Can you tell us why? Waiting for Euromet. the reason it's pending and for the result of your amendment?
Yeah, I don't know how Euromet started a comparison without because this comparison, the RMO comparison, formally does not have a reference value. The only reference value that exists is the CC, the KCRV. That's the reference value. No, there's only one reference value. And the one reference value is the CCT reference value in this case. Now, temperature in general, it takes a long time to do these things. So I don't know.
Says that we are waiting. Outcome.
Well, because this is an
The issue will not be started. The Gulf Med key comparison should not be started until the, yeah.
well, it's a decision of the RMO. If they want to start, they can, but they cannot link.
No, the issue, they cannot link. And they wait. I don't know how it's the, because
I don't know about thermometry. I don't know what they're doing. Maybe they have to produce two reports. One which is a first report which is with no link, and then a second report which will include the link. I don't know. I don't know.
with no links.
It's not a key comparison. It's not a key comparison. It's not an RMO key comparison with no link. No. I mean, they can claim, look, in Europe, they can probably claim. Huh?
In Europe,
Yeah.
but in our area.
Because you have PTB, you have metas, you have this, you have that. So,
Confident.
yes. So they can probably claim. But in Africa, they cannot claim. In GCC, I don't think that they can claim. Hmm. Yeah. In general, for temperature key comparisons, I know that they take a long time anyway. I mean, they take a long time because there are many labs. Everyone has temperature.
No, something, I think predicted that they are asking this.
Something, Miltiades was telling me, something happened with the standard. I don't know. Something, I don't know.
It's out. He said that we are.
Hmm.
What do you in case it, but this is it's start and not he's not following the.
Well, the big guys make the procedures anyway, so they're allowed to alter them. Um, yeah. This is an old one, right? It's some years now, or am I mistaken? 17. Yeah.
There's just have to decide whether. But our I think that I haven't.
Mm.
I see aging.
So this scheme here is based on the fact that both the reference values of the CC and the RMO comparison are known. Okay? That's the only way that you can shift from one to the other if they're known. Otherwise, you cannot shift. So there are some assumptions that are made. Okay, one assumption is that this value here doesn't contribute because the double participating labs are thought to be reproducible. So whatever value they got, the transfer standard in the RMO should be the same as the value that they got um, the CC comparison. And yeah, so it's just a matter of shifting after that.
Horrible. Why I am going, and this is happened with IR. They propose the argument, the IPM, that no, you cannot do key. For me, as an argument, as supplementary, how can I?
You cannot.
Why? The whole issue thing, it's why we are doing it.
No,
How we that it's that's why CMC to you.
there are different levels of this thing, right?
Okay.
So I presume that you cannot have key comparisons for everything out there. So you have key comparisons for some, not laboratories, some key quantities, some key issues, right? So in mass, for example, you have a key comparison for 1 kilogram. You have a key comparison for multiples and submultiples. And you have one for 50 kilograms, and that's it. You cannot have. So for example, someone wants to publish CMCs and balances, in balance calibrations. There's no key comparison for that, and there will never be. How can you do that? The supplementary comparison was designed for this purpose, to support CMCs in situations where key comparisons don't exist. Now, I presume it works easier for the larger labs and for the older labs than for the new. So a newer lab, they would probably say, well, no, first publish CMCs for which key comparisons exist and then go on to that. Maybe, I don't know. Maybe they'll accept it. But that's the reason why supplementary comparisons exist. Hybrid, I don't.
And APMP, they are using it.
Yeah, I know. I don't know who came up with that. The Chinese came up with it, I don't know.
It's been approved. There is, you know, the normal. People.
No, they have been, they refused it. Remember, I sent one
different. They are hybrid.
comparison and the supplementary.
No, there is other. Right now, it's been approved by JCRB. There is what they presented by APM, MP, and it's been approved by GCRB.
Yeah, it's been
And you
approved.
can claim by doing hybrid.
How many labs have claimed CMCs based on hybrid comparisons?
I don't know. APMP, they are doing it frequently.
How many have claimed CMCs based on this? That would be interesting. Because even APMP says only in the case where you cannot find other means to support your claim. This is made clear that they will not accept it unless there's nothing else available.